So we've been solving systems of equations by graphing, which is my favorite method, but it's not always the most practical. Sometimes you're not going to have a graph, or the equations that you're given will be nasty to graph. Like they might have y-intercepts that are fractions, or your solution might end up being a decimal. So there are some scenarios where we need a different way to solve a system. And one of those ways is using substitution. When we're using substitution to solve an equation, the basic steps are to solve, substitute, solve, substitute, solve. So we're still looking for our final answer to be a point on the coordinate plane. So we need our answer to have an x value and a y value. So we need to solve for both. The first step is to make sure we have an equation that's solved for one variable. So we need something that says x equals or something that says y equals. Once we've got that, we can substitute. We're going to take that first equation and substitute it into the other equation we're given. Then we'll be able to solve that equation, and we'll find out that like x equals 5 or y equals 7, we'll get an answer. Once we have the first half of our answer, we can substitute that value back into one of those equations and then solve for the other value. And our final step is to write our solution as a coordinate pair. So that means in parentheses, all of our answers would look like x comma y. Once we have an answer, we can check it and make sure that we got the right answer. So we're going to do one example in this notes page. And then we're going to do one example just on the next page in your notebook. So our first example in here has the equation 3x plus 3y equals negative 15 and y equals 2x plus 1. So step one said that we needed to solve an equation for one variable. We need an equation that says x equals or y equals. And we've got that. We have an equation that says y equals 2x plus 1. Step two is to substitute. So what I'm going to do is substitute this equation, 2x plus 1, into the first equation. So I know y equals 2x plus 1. So that means where there is a y in this first equation, I can substitute 2x plus 1. So what I'm going to end up with here is 3x plus 3, and then instead of y, I'm substituting 2x plus 1, and that equals negative 15. So that was step two. We did the substitution. Step three says we need to solve this equation. So my first step to solve is to distribute. So now I have 3x plus 3 times 2x is 6x. 3 times 1 is 3 equals negative 15. My next step is going to be to combine my like terms. 3x plus 6x gives me 9x. So 9x plus 3 equals negative 15. Now this is just a two-step equation, so I subtract 3 on both sides. 9x equals negative 18. Divide by 9 on both sides, and x equals negative 2. So this is half of my answer. I know that the x half of my answer is negative 2. I still have to find the y half of my answer. But we did the hard work already. Now that I know x is negative 2, I'm going to look back to my original equations, and I'm going to choose the one that I think looks easier. And I think the second one looks easier. I'm going to substitute x for negative 2. So that's my equation from the beginning, y equals 2x plus 1. I know x is negative 2. So I'm going to do substitute -2 where x is. So now I have y equals 2. In parentheses, I'm going to substitute -2 plus 1. So that means y equals 2 times -2 is -4 plus 1. Y equals -3. So that's the second half of my solution. My final solution would be -2, -3. To check this solution, I would go back to my original equations and I would plug in the x and y values that I found. So in the first one, this would be 3 parentheses -2 plus 3 parentheses -3 equals -15. And I want to make sure that is correct. 3 times -2 is -6. 3 times -3 is -9. So -6 minus 9 equals -15. That is correct. In the second one, my y value is -3. My x value is -2. So I am checking to make sure that 2 times -2 plus 1 is equal to -3. 2 times -2 is -4. So this says -3 equals -4 plus 1. That's totally true. So that means my answer is correct. The point that I found is a solution to both equations, so that is the solution to my system. So this page is going to get glued into your notebooks on your next blank page. In my notebook, that next blank page is page 62. So in my notebook, these notes are going on page 62. And then we're going to put in one more example on page 63. So our example on this page will be the system of equations y equals -x plus 1 and y equals 2x minus 5. This system would be a great candidate to solve by graphing because both of these equations are already in slope-intercept form. But unfortunately, I do not have a graph that I could graph these on. So instead of solving this by graphing, I'm going to solve it using substitution. So I know my final answer is going to look like a point on the graph. I need to find the x value and find the y value. So our first step in substitution says to solve an equation for one variable. Pick the easier equation. We're trying to get x equals or y equals. In this case, both of these equations are already solved for y. So step 1, totally done. So I know that y is equal to -x plus 1. In step 2, I'm going to substitute. So my second equation says y equals 2x minus 5. So when I'm substituting here, I know y is the same as -x plus 1. So I would take -x plus 1 and substitute that where y is. So in my substitution step, I'm going to have -x plus 1 equals 2x minus 5. So the equation we end up with here looks different than it did in the first example, but this is still an equation that I can solve. It has an x on both sides, it has constants on both sides. So my first step would be to cancel out one of these x's. And to keep things positive, I'm going to add x to both sides. So now my equation says 1 equals 2x plus x is 3x minus 5. From here, this is a two-step equation. So I would add 5 to both sides. So 6 is equal to 3x. Divide by 3 on both sides. And 2 is equal to x. So that's the first half of my answer. I know that x is 2. Now I have to go ahead and find the second half of my answer. To find the second half of my answer, I have to substitute again. So step 4 says substitute the value you found into one of the original equations. The value we found says that x equals 2. So when I go back to my original equations, I get to choose one. It doesn't matter which one. I'm going to choose the second one. And in this equation, I need to substitute 2 where x is. So now my equation is going to say y equals 2 times 2 minus 5. 2 times 2 is 4, and 4 minus 5 is negative 1. So y equals negative 1. That's the second half of my answer. So my solution here is the point 2, comma, negative 1. I can check this solution, and I highly recommend you check your answer. So you would go back to your original equations, plug in the x and y values that you found, and verify that that point 2, negative 1 is a solution to both equations. So these problems take up a lot of space in your notebooks, and they also require that you are carefully working your way through this. If you make one small mistake with a negative sign, everything that comes after is going to be wrong. So make sure you use a calculator when you're practicing these today. Go slow, go step by step. Finish this check before you grab your practice from today from the substitute, and make sure you turn that practice in at the end of class today.